everybody, hello from Romania, from our favorite artist electronics, Mr. Q12 here. So I managed to make a proper test for the power dissipated over LM317 voltage regulator, pretty much. And here is the diagram. Here is like a simplified circuit, what I'm having there. I'm only suggesting that this is a voltage regulator for tests and how to link it here. So that's why I put here some dotted lines, because if I'm not using voltage regulator and only testing transistors, I will use only this line here for testing transistors only. But if I'm testing voltage regulators, that's why this line is dotted, because I will cut it from here and from here, link it like this. The power will go through the voltage regulator and coming out from its V out there and coming into this transistor. And instead of this line is this entire circuit. The power will dissipate over that. And here it will be more power dissipation and less through the transistor when this is activated, pretty much. This is the actual circuit that I'm using here. Now, when I'm looking here, I put 1.6, but in reality, I believe I put... it might have been a little bit less than 1.6 that I've noted here. Probably 1.3 or something like that. So it's not exactly perfectly this. I tweak it to obtain there a perfect 3 volts from the output of the regulator, pretty much. This P1 and P2 represents, they means 0.1 and 0.2. As you can see here, I'm receiving 5 volts in the input of the voltage regulator, and I set it up to output 3 volts here. So that's the thing. So this P1 and P2 points are these points from here, 0.1 and 0.2. Here I'm specifying where they are linked pretty much on this diagram, on 0.1 and on 0.2, and that's it. That's the meaning. And this is the pin out of LM317. You can see this laundry tongue, I believe it's called, here. It is here to keep my temperature probe, which I don't like it at all, the way it's built there. This is from my temperature meter that I'm having here. So this is the circuit that I'm using. Make exception of this potentiometer that I'm having here. I was thinking to add a secondary potentiometer here in the diagram. I just leave it there, and that's not actually used here. The intention of this potentiometer was to get a bit more resolution when I'm changing the values, the current flowing through everything there. The power management, you know, it's a bit more convenient with that. You see here is a blue resistor, is 2.2 kilo resistor. Originally, when I made this entire board and progressing the thing, adding this radiator and the transistor and etc., and I took out that resistor and I changed it with this simple wire, and it gave me very good results when I was using this 5.6 ohms resistor at 2 watts probably. And the travel of the potentiometer was very smooth, and the changing of the amperage there was normal. It was not jumping, and this was a problem actually for a very long time, and it still is, even with that blue 2.2 resistor that I put now. So when I was still having this wire, when I switched to this 1 ohm resistor here, it was starting to jump as low as I could rotate this very fine movement of the potentiometer here. This amperage was jumping like crazy between hundreds of milliamps. So 200s, 800s, 1.5, stuff like that. It was crazy. And now when I put that resistor, it is a little bit more calmed down. But when I'm and this is for 5 volts, but for 9 volts is jumping again. So it's not probably this circuit that I'm having here is not that good for too much variation. And for the thing that I'm trying to do here, all this thing is having a little bit of bottlenecks, pretty much, and this is one of them. This is one of those bottlenecks. You should be able to switch that resistor with a link, or probably with a bit more higher value resistor than it is there, and to make a very smooth transition range, travel of the potentiometer. That's the only. This is the problem that I'm discussing here, but it is highly dependent of this power resistor loads that I'm using them here in the back of at the end of the circuit, which are these two here. So, and this is the pot here, and here instead of that wire is a 2.2 resistor, blue thing. Yeah. Okay, that's enough for the circuit. The setup that I'm having right now is that I already soldered this leg of this 1 ohm resistor, so it is bypassing this 5 ohm resistors, so it is activated, this 1 ohm. This is the links that I made. I put exactly like in the circuit that I showed there. Actually, this is the power, and here is the collector. So this is the power, 5 volts, that is coming into the input. V in is this last pin here, so it's there. That's the voltage regulator, if you can see it. You see it? So it's having there V in. This is V out, and this is adjustment pin, and it's having these legs, spread like that. So this is the middle one is V out. You see, the middle one is V out, and is going directly to the chassis of this heatsink, and is actually connecting to the collector of this power transistor that I'm having here. That's what it's doing. And that's the setup that I'm having right now. I'm having a very small voltmeter here that I recently purchased exactly for this reason of being small, extra mega small. And I would like even smaller than this, but these are cute. I bought 2 of them. They are crappy, very crappy. But what I like about them is their very small size. And what I'm doing with them is very limited. I'm only measuring some voltage and some resistance. I did measured with this one specifically. It's having some really seriously. This is mental. This is retarded actually to put 1.5 volts here to measure batteries. Seriously, no way. So this is retarded from my point of view, of course. Okay, so it's so I set it up for beeping, and it's also very shitty on beeping as well. You see, it's having a large delay response. It's not you see, it's not instantaneously. You have to wait like, I don't know, 500 milliseconds, half of a second or something like that. Or yeah, it's not sky high problematic, but it's a shitty design. It's a shitty integrated circuit that is dealing with this, probably a microcontroller or something. So that's but for what it is, for the space that is occupying here, I really like it. For the space and for the function that I'm using it as a very simple voltmeter, I really don't like turning it to off state. I will probably make a button for it to quickly switch it on off, depending. Doesn't matter where it is left off, so I will do that in the future. And for both of them, like I said, I have both 2 of them. I made this little is from a piece of metal sheet, and I bend it around this diameter, and now they are fitting action in there. And yeah, and I soldered a wire to there, and that's how I'm having this little probe extension probes here for my voltmeter probes. So yes, now let's talk about the data. Collecting the data was with a little bit of hiccup and a little bit of mistakes. And we all learn from mistakes, probably. Some of us are screwed for life, traumatized for life. The idea is that I did collected some data, and I did it for 5 volts. An American friend, they suggested me that 5 volts is not really proper, yeah, for the voltage regulator to operate at, especially when I'm doing these testings at higher power dissipation through them. Probably they will work fine without power dissipation or stresses that I'm doing here at 5 volts. But in these conditions that I'm doing it here, probably is not. They suggested me that I'm having some fucked up values. I will repeat the experiment right now just to show you the results that I got. So right now is 5 volts with 300 milliamps, 0.3 amps. And we are here, or here if you want. So let me explain what this table that I made here is all about. VO is V out, is from here, from this point to the ground. I took the voltage from this point, from V out to the ground. And how I did that, let me show you. Like that is this. I connect. I already set it. I have it set it up. This voltmeter to this exactly to this V out points to measure it right now. So my power supply amperage is 0.3, as you can see there, 0.3 at 5 volts. This 5 volts is constant for this table that I'm having here. And voltage on VIVO, V in, V out is this points I measured. V in and V out over pretty much what I did. I measured from this, or this V in and V out. So pretty much I measured over this voltage regulator. I got a range actually here when on the 0 volts or the 0 amperage. So this amperage that I'm setting here, that I'm obtaining this variable values, 0.28, 0.30, 40, 60. I'm actually turning the knob here, and I'm watching that amperage that is changing there, 0.3 there. So that's what I'm doing. When I'm changing from here, I'm watching there. And when I'm reaching, when I'm turning enough from this potentiometer, and when I'm reaching a certain value, I'm stopping, and I will not switch anymore, and I leave it, and then I start getting this voltages, this other data that I'm having on this when it's stable, when it's not fluctuating, when it's not moving at all. So now on V out, we are here on line 2. So let me talk about line 1, because this is important. From 0 amps so to around 0.28 amps or 280 milliamps, V out, the output voltage of the regulator is 3.2 volts here, and it's stable, is unchanging, is not varying at all in this range. But the voltage over the regulator is lowering, is decreasing as long as I'm increasing the amperage here, is decreasing a little bit this voltage over this voltage regulator. So that those 2 points are changing a little bit, are decreasing. And I put an arrow here to suggest, to show, to exemplify that it is decreasing, is going down, is ramping down. And this is the calculated, this is the wattage of the voltage regulator using this data that I'm having here. So what I did here, I calculated this amperage times this VIVO this voltage over the regulator, and I obtain that wattage over the voltage over the regulator power dissipation. But I forget the temperature. You see here, I don't have anything. Only here on the last one, I remembered to take the temperature, and it was 63 degrees Celsius, and I stopped everything after that. So this is the first line explanation. Again, for 5 volts, and this is when I increased the knob here and the amperage. The amperage is increased to 0.3 from 0.28, and I got a less value here, and an increase, a little bit more increase wattage here, and the V out is starting to ramp down. Here is from 3.2 is ramping down to 3.19, and here to 3.10 now. So the voltage, the output voltage is lowering in this situation when I'm increasing the amperage. This is actually, this amperage increasing is the consumer power, the consumer amperage demanded from the regulator. So I'm having a variable amperage load that is demanding more and more amperage as long as I'm increasing the knob here. Pretty much that's what I'm doing. I'm increasing the amperage here, and this must deal with that increase of amperage, and also increasing power, because this will increase the power dissipation over it, and it will hit up higher and higher as I'm increasing the amperage demand from the load here, from the consumer, pretty much. So this is the consumer here, which is variable. All right. So now I increase it to 0.40, and you see that voltage, output voltage is decreased here, and right now what you are seeing here is 3.18. You see, and it's here. And let's change to actually show you that this data is absolutely perfectly correct. So we will change from 0.30 to 0.40. So now is 0.30, and I will change from here until, you see, and I'm looking there until I will get exactly 0.4, like that. And I'm stopping from moving it. You can see the knob is moved there. So when I increase to 0.40, like that, I was getting 3.10, and here I'm having 3.0809. For some reason now is a little bit changed. I have no idea why. Most probably because this is actually functioning for probably half an hour or more than half an hour already, and they got hit up, and most probably that power dissipation or temperature, increase in temperature, modified a little bit this result from the one that I'm having it here when everything was cold. So now is a bit warm up everything. So I'm getting a tiny little bit less value that I'm having here. And how I'm getting this value here over the regulator is like this. So I'm taking this out from here, and this is the V in here, and hopefully you can see some shit there. So there it is. 1.75, and it's exactly or very close to what I'm having here. Remember, all these values were, I took them when it was cold. Right now it's a bit warm up, unfortunately. It's my excuse. It should be 79 there, not 76. Yeah, well, so this is how, even if I'm getting a negative value because I'm using the negative probe here, but it's the same thing. It's no problem. And this value here is the calculated value from amperage times voltage over the regulator. And I'm getting this increase in wattage here. And here, I will not switch it to this last amperage 0.50. I will only show you the voltage over the regulator is increased again, and the wattage also is increased again, and the V out, the output of the regulator, is lowered significantly. Is lowered, but the temperature was very high. It was 63. So you see, it's 63. It was 63 degrees Celsius, not Fahrenheit. So degrees Celsius, and it was the last, the first time when I took the temperature here, and it was too late already, and I stopped the experiment. So that's this is the 5 volts data reading that I took. Okay, next table. In the next table, I took 2 voltages actually, because I was discussing with my friends, and my American friend said that yeah, it's not actually good to take the voltage from 5 volts because it will not give you a realistic result, because this voltage over regulator is less than 2 volts here, and it was his observation. I didn't catch it by myself, and that's why it's good to talk with people, because they will steer you in the right direction. The voltage regulator specifications, the minimum is 3 volts, so I was under 2 volts over the regulator here, and you can see the other data as well. So 5 volts minus 3.2 is 1.8 there, and is exactly, if you calculate this 2 values, you will get the voltage over the regulator without making any measuring with the multimeter. My friend from America, my American friend, his experiment that he was doing was at 9 volts. So this is a very big problem with this circuit, that this potentiometer, if I'm leaving it at this position and I'm switching the voltage from my power supply from there, it will increase dramatically the power over the power transistor and over the tested component that I'm having there. So I have to bring this to 0 here. Nothing is consumed, is very low, and now I can safely change the voltage. So now from 5 volts I will go to 9 volts here. There it is. Okay. Excellent, good. What I did here, in this top part here, I took the values from here, the most important ones, and I also double checked in the same time, and I took the temperature again for this to double check it. If here it was 63, here was 68, but for 10 minutes. So this here is actually a copy from this, but double checked. So I measured everything again. I also changed a little bit the order of this measurement points that I'm having to be easier to calculate stuff. So the thing is, make abstraction of this part and this part. So these two, I'm covering them like that. So don't make abstraction of them, because I'll talk about them later. So right now is about 5 volts until this very big line here. And from this very thick line that I'm having here down is 9 volts. So this 9 volts from the power supply is constant. Here, I'm only changing again from the potentiometer here, and I'm looking on my power supply amperage, and I'm looking here, and here I'm changing the amperage. Actually, I got too far here, the first one. So this line is a bit too high, also in degrees Celsius, in temperature, and also in wattage. As you can see, I got to 1.44, but I took it, I put it down as a measured value, and then I bring down the amperage to be in parallel with what I had when I measured the 5 volts. So pretty much what I'm having here at 9 volts is the same for the wattage that I had for 5 volts. So check this out. So here, line 1, 2, 3, 4, line 4, I'm having 0.57 watts over the regulator, and at 5 volts I was having 0.52. So it's very, very close to that. And here as well, on this line here, line 5, I'm having 1 watt, and here I was having 0.92. So that's these two and these two are equivalent, okay, in wattage at least. And also in temperature, if you watch the temperature, is still 47 here, and here 68 because I waited more time, and here is 65 because I waited less. Then I discussed with my friend. Well, I knew these things before, but getting away with the experiment, I kind of forget about it, and my friend ring the bell about it, telling me to actually get the amperage in the circuit, to get the amperage from this line somewhere. This is the line that I'm showing it here. So from somewhere here to get the amperage, and not rely on the power supply amperage that I was doing here from the. This is how I did this wattage calculation, using the power supply amperage and this voltage over the regulator, and I was getting this wattage over the regulators. And my idea was to get the voltage over this resistor, which is 1 ohm. And when I'm getting the voltage over it, I'm actually getting the amperage without any calculation. So that's it. 1 volt per amp pretty much is what I'm getting here. That's the summarization of 1 ohm resistor. So pretty much I was collecting the amperage over this resistor. By getting the voltage over it, I was actually reading the amperage that is flowing through all this circuit that I'm showing it here, through the regulator, through the transistor, power transistor, and through this 1 ohm here resistor. This is more close to reality, but is not that far away in the same time. So the values are less here than here. The amperage that I took it from over the 1 ohm resistor is this. Well, we will look here and here, 0.05 instead of 0.10, and 0.12 instead of 0 octave. The new wattage from this 1 ohm reading over it times Vivo times this voltage. So 5.74 times 0.05, I'm getting this new wattage over the voltage regulator. And the same here, this voltage here times amperage that I took it from the resistor, and I'm getting this new wattage 0.69. In comparison, this new wattage is 0.3 almost, and this was 0.6, so almost 2 times less wattage than when I use the power supply. So it's a little bit serious difference, you know. And this is 0.7 here wattage, and this is 1 wattage, so 1/3 less wattage than my original calculations. So that's how you must calculate your stuff. So this was the boring part with these tables, but it is boring in the video, but it's extremely helpful in reality when you have to compare stuff and to figure out what is what, and what everything is doing out there in your circuit, because everything is like a black box. You cannot see and feel anything from it, and you have to calculate some shit. And that's it for this part. So this test is telling me you were right, but not completely, because it worked fine in 5 volts mode as in the 9 volt. In 5 volt mode is getting a bit more evident that is going down from the regulation, while in 9 volt mode is not that evident, but it is still giving clear signs of ramping down, but at a less steep angle than in 5 volts. Saying how increased voltage is strengthening this ramping down. is less evident pretty much. Before I started anything in reality, I actually made a test here in Proteus. Here is a voltage. This is an ampermeter here in line with the regulator here, and this is the voltage that I'm getting across the regulator here. And here is the data that I collected. This potentiometer percentage. You can actually see there is a percentage. You see, it says here 100%, and if you are getting lower and lower, you see this is the percentage, and you fine-tune it from these two buttons, and this is how I was getting the percentage from this potentiometer. So what it's telling me exactly this ramping down problem that I encountered. This is very important. This is why I wanted to make this movie. So this is V out, which is here, this point that I got it. I'm not showing it here, unfortunately. Actually, I do. I am. This is the V out probe that I was using in Proteus simulator here, and this is showing me the voltage from this point, this output of the regulator to the ground. This is the connection, and this V out, we are looking here on these values, and what we can observe, and this is the most important thing, is that from here to here, all these outputs are the same, exactly, perfectly the same outputs. 3 volts, 3 volts, 3 volts, 3 volts, and now it's starting to decrease a tiny little bit, 2.95 volts. But look when the potentiometer is from 0% to 50%. And this is very interesting and very weird. And when the potentiometer is 55% here, is ramping down, this output of the regulator is ramping down to 1.66. So it's very, very low. But the amperage is jumping up. And most importantly, the wattage is 5 watts. Before it was 5.85. It was increasing slowly but surely. But then it's like a jump, like very, very, very short distance, you know, from 50% to 55% of the, when you turn the knob, is jumping to this wattage that I'm having here, extreme wattage. And then, so here, let me use an arrow. Here is constant, but here the voltage decreased, but from here the voltage is increasing. You see, is 1.5, 1.9, 2.2, 2.4. So here is decreasing. So here it, and here is constant. Here is constant like this. It's constant, 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 but voltage decreased fantastically fast, and then started to increase as long as I was increasing the potentiometer value towards from 60%, well, from 55 towards 100%. That's the issue. And the wattage is decreasing here, as you can see. Here is 5 watts, and then it's decreasing, decreasing, and decreasing. The amperage is constant. The amperage is pretty constant, so it flipped. So this is constant here, constant, 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 constant. So you see the relation when the voltage, and also this one is constant as well with the rest here. So I should probably make it bigger, like this. When the voltage get that point, when it jumped down to this value 1.66, in my case, of course, probably it was a little bit lower, but I didn't catch it. Then it switched to this constant amperage here, while the V out was starting to increase. In the same time here, while this output was constant, the amperage was increasing. You see, here is increasing from 0 to 1.4 amps. So you see this this relation from the amperage to that output voltage. So this is the input current here on this column, and here output theoretically regulated voltage of the regulator. All that I'm saying here, all that I'm explaining here is about the regulator, as long as I'm increasing the potentiometer value. Okay, and the problem is why is jumping after a while, you know, in the middle of the potentiometer travel, and the response was that it might kicked in the thermal protection when it's doing this. When it's doing this, probably the thermal protection is kicking in. What I was expecting from a voltage regulator when the power is overwhelming over it, I was expecting the regulator to stop completely, to cut the power, or to maintain this output voltage constant. Doesn't matter the power, but instead what it's doing, this is not going to zero, it's going to something over the zero. And the wattage is jumping up, the wattage extremely high, and it's a very weird behavior. I didn't expect that, and that's the issue. That's the problem that I faced with, and I stayed like a couple of days and I'm thinking of it. That regulator is rated for 1.5 amps. Looks like internal circuit limit is kicking in, and I am aware that feedback inside thing is kicking in, and I was aware of it all the time. But it's still a very strange output behavior. That's my idea that I want to say. What I'm showing you here is the setup that I'm having, how I'm using this variable power load circuit that I'm having to test a voltage regulator, because this was the initial idea to test these power regulators. And my American friend said, build a variable power load. And it was a great idea. And I was actually, after this kind of power load myself, I was thinking of it for a very long time before. And when he came with the idea, I jumped right up and I started building it, and this is the history of this. This is extremely helpful device that I'm having. These values that I'm getting here, I will use them in the future tests that I will do with heat sinks over the voltage regulator. So this will be extremely helpful, this data that I'm collecting right now. And we'll see until then. All right, that's it for this part. Thank you very much for watching. And bye-bye. 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 From your favorite artist electronics, Mr. Q12.